In this video, we're going to go over the notes for lesson 4.8. So we're going to kind of analyze graphs of polynomial functions. All right. So this first section here kind of just gives us some basic terminology and parts. It starts off here by telling us about the basic form of a polynomial function. Okay. Starting off with some coefficient a times x to the n power. So that's going to be the greatest power of n. And what you kind of really need to look at this and realize is all it's trying to say for this function is as we move to the right here, we're going to get increasingly smaller x values until we get to a point where our x is now going to be x to the 1 and then eventually x to the 0 and it's gone. So it's just trying to say a polynomial function, right? It's just trying to put it in order from from greatest to least in terms of the power of our degree. Our next part here is it's kind of just telling us these are kind of all the same thing here. These are all sort of the same. Okay, what we're really looking at here, the zeros, the factors, our solutions, our x-intercepts, they are all really the same thing, just in different words, right? So to kind of get us a review, let's say we look at a quadratic. So if I were to graph a quadratic, I might get something that looks like this, right? Now, our x-intercepts are right here and right here. So we have two x-intercepts. Those are also going to be known as the zeros of our graph, right? The zeros. So we can also call it the zero. And so we have, let's say this is the coordinate -2, 0. I should probably put the comma 0 in there. So -2, 0, and we'll call this, say, 2, 0. Okay, those are our x-intercepts. Now, kind of working backwards, okay, we could rewrite those as a factor. Okay, we can use a factor with it. So that's where we're going to get, or actually, we could write it as a solution. Kind of work backwards. Okay, so we take these x-intercepts that we have, right? So we know that x is equal to -2 here, and x is equal to +2 here. So kind of working backwards, moving the -2 over and the +2 over, right? We would get x is equal to, x plus 2 is equal to 0, and x minus 2 is equal to 0. Okay, so this x minus 2 and this x plus 2, right? Those are going to be our factors. Okay, we're taking x minus or x plus some number k, okay, which is k being the 0, being the x-intercept of our graph. Okay, that's just kind of what this terminology here, just to kind of remind you what a root is, what a factor, the solution for our problems are. Okay, but what we're going to get into today is kind of looking more at the end behaviors and the way our kind of graph is going to be shaped and move around. All right? So looking here at the bottom, we can see we have 4 different potential options of how the end behaviors of our graphs are going to look. Okay? And those are going to be purely based off of the degree and the leading coefficient. Okay? Now let's review what a degree and a leading coefficient is. Okay? So the degree is going to be the highest power of your polynomial. So let's say I give you a polynomial such as, we'll say 2x cubed minus 3x squared plus 4x minus 5, right? So if I give you something like this, you can see here that our degree, highest power degree, is 3. It is also odd, okay, in this particular instance. Now, the leading coefficient, okay, the leading coefficient is the coefficient, which is the number in front of our variable, okay, is the coefficient of the term with the highest power. So in this instance, x to the third is my highest power term here, so 2x to the third, and my coefficient is 2. Okay. Now, how that affects our end behaviors, okay? We have 4 different options, like I mentioned previously, for how our end behaviors are going to respond. Okay? They are purely based off of our degree and our leading coefficient. So in this instance here, I have a odd coefficient, an odd degree with a positive coefficient, right, at +2. So when I have a positive coefficient and a odd degree, my end behaviors are going to respond like this. Okay, so as our graph, right, as our x approaches negative infinity, right, this is our negative x, this is the positive x. So as we go infinitely negative direction here for our x value, okay, it says our y value, f of x, right, f of x is the same thing as y, is going to go down towards negative infinity. So we could say as we go left, okay, as we go left, or we might even call that x towards negative infinity, okay, as we go left towards x equals negative infinity, our y value, okay, is, we're going to say f of x is going to approach negative infinity as well. We could also call that, say it's going down, right? It's going to go towards negative infinity, so it's going down. As we move to the right, so as we go to the right, so as x approaches, so we use the arrow to show approaches positive infinity, okay, our y value is going to approach positive infinity. So our y value is going up. Now let's write those out for all our other 3 problems. So when our degree is odd, our leading coefficient is negative, right? We're in a situation where as we go towards left towards negative infinity, our y is going to go up towards positive infinity. As our x approaches positive infinity, our y goes down towards negative infinity. So it's kind of the flip-flop of this, okay? So because we now are starting with a negative as our leading coefficient instead of a positive, right, it's kind of flipped. So as I go right, okay, my y value, my f of x, approaches, as I move to the right, our y value approaches negative infinity. As I go left, my y value, my f of x, is going to approach positive infinity, right? It's going up. And we'll add down for that. Okay. Now we're looking at our even degrees. So these are the 2 instances where we have an even degree. If our leading coefficient is positive, our numbers go up. If our leading coefficient is a negative, our numbers go down. Very similar to how our quadratics worked, right? Our quadratics were working in the form of ax squared plus bx plus c is equal to 0. Whenever a was a positive, right, our graph went up. Whenever a was a negative, our graph went down. Kind of the same idea here, right? Because we got a positive power here, an even power, so we go up, right? We're working the evens. They both kind of going in the same directions. So let's look at here. Let's write our answers out for this. So we can say as we're going to the right for an even and positive, our f of x is going to approach positive infinity. It goes up. The same is true for when we go towards our left. So as x approaches positive infinity, our y value, our f of x, will approach positive infinity as well. It will also go up. Now, when we have a negative leading coefficient with an even degree, the opposite is going to be true. So as I move towards the right, our f of x, so as I move towards the right, our f of x will approach negative infinity. It will go down. And as I approach it going towards the left, our f of x will approach negative infinity as well, and also be going down. So that is our kind of the directions at the ends of the graph behave. So they're either kind of both up, both down, one left, one right, or one, the opposite, the flip for that. Okay. Now let's kind of look at something a little bit different. So how the middle of our graph is supposed to kind of react. So those are the ends of our graph. Now let's look at the middle of our graph. And this is where we're going to get into multiplicity. Okay, multiplicity. So when we are solving our polynomials, our problems, sometimes what we'll notice is that we get the same answer twice, right? So for example, you might get the factors x plus 8 and x plus 8. And then you work that out, right? You get the solution, your zeros as x equals -8. Obviously twice here. Okay? When this happens, when we have two of the same answer like that, we would say in this specific instance that the zero, right? The zero of our graph, -8, so 0, -8, has a multiplicity of 2 because there are two of the same answer. Okay? If I had 3 x plus 8s, I would then say that the 0, -8 has a multiplicity of 3. Okay? And we could keep going and going depending on how many of that same answer that we have. Okay? Now, let's talk about how that's actually going to affect our graph. Okay? So let's say we look at something like this where we have a single zero. So let's say we just had a problem like this where we just said, we got x plus 5 as our only factor for this part. Right? We only got one x plus 5. Okay. Then we would say that, hey, this x is equal to, so our 0 of -5 has a multiplicity of 1. So this 0, so the 0, -5 has a multiplicity of 1. Sorry about that. So the 0 of -5 has a multiplicity of 1 because there's only one of them. But let's say I had two of them. So let's say I got 2x plus 5s. Right? So I got 2x is equal to -5. I got that twice, right? Then I would say that the 0 of, and actually we might change this so it's just not as confusing with it. Let's change this to 6, just to show it as an increment. Okay, so x equals -6. Okay, I got that twice. So the 0 of -6 has a multiplicity, and we can say, our multiplicity of 2, because I have two of the same answer. Okay, and then let's go to our last one here. Okay, we have our x plus, we'll just say 8, x plus 8, and x plus 8. Okay, we have 3 x plus 8s. So the 0 of -8 has a multiplicity of 3. Okay, now we kind of talked, how to write this out, but let's actually talk about what's actually happening here. Okay, so when we have a single multiplicity, so a multiplicity of 1, our graph just passes right through that point. It's not going to change anything, nothing's happening with it, it's just kind of like normal. But when we have a multiplicity of 2, or actually any even multiplicity, okay, any even multiplicity, as our graph is going to approach that x-axis, instead of going through it, it bounces off of it instead. Okay? Then we can look at our last one, our multiplicity of 3. Okay? It works pretty much the same as the multiplicity of 1. It essentially is going to pass right through it. Okay, it kind of flips it in a way, but not really. Kind of weird little wiggle. Okay, but essentially it's just going to pass right through. It's still going to kind of still follow the same general idea with it. It's still following through. Okay? So the only one that's kind of different is anytime we have a even multiplicity, it bounces off. An odd multiplicity, it passes through. Okay? Now let's go back here and let's review. Okay, so let's get some practice problems in here. Let's review. So we have here 2 problems. Okay? So I want you, well, 3 problems on this page. I want you to take a moment, pause the video, try these 3 problems. Okay? Try these 3 problems, and then we will go over those. Okay, hopefully you've had enough time to go over those on your own. Let's go over these together. Okay, so our first one here is we have negative 3x to the 6 plus 4x squared minus 3x plus 6. Okay, a lot of words there. What you'll notice is they were very kind to us, and they put these problems here in standard form. Okay, they put them in order from greatest to least in terms of the power of our x's. Okay, so in this case here, let's find our degree. Okay, the degree of this problem, right? Remember, the degree is the highest power that we have. So the highest power I have is 6, which is a even. Okay. Our leading coefficient, we'll just say LC for short. Okay. In this instance here is negative 3, right? It's the the coefficient in front of the term with the highest power. Okay. So our leading coefficient is negative 3, which is a negative. Okay. What really matters is if it's even or odd for the degree, positive or negative for our leading coefficient. Okay. So when we have a even degree with a negative coefficient, okay, that is the instance here where we're going to have both go down in the same direction. So even degree, negative coefficient. Okay, so our answer for this one would be let's see, from the left. So from the left, as our going to the left, that is rather going to the left. Our y value, so our f of x, is going to approach negative infinity. As we go towards the right, our f of x is going to approach negative infinity as well. So they're both going to go down. Okay, so describing the end behaviors, they're both down. All right. Now 8 is a little different because they didn't put this nicely in order from greatest power to least power, right? Okay, so hopefully we can look in here and figure out that, hey, this 3x to the 5th is the greatest power in here. So really, the degree of this polynomial function is going to be 5, which is odd. Okay, then we can look at here. We have a positive 3, a plus 3. Okay, so our leading coefficient, it's not the number in front. Remember, it's the number in front of the greatest power. Okay, so our leading coefficient is positive 3, which is a positive. Okay, so when we have a odd degree with a positive power, okay, that is when our graph is going to look somewhat like this. So we know that as it goes to the left, so as our x approaches the negative infinity, our y value, our f of x, is also going to approach negative infinity. So it is going to go down. And then as our x approaches the positive infinity, so going towards the right, our f of x also is going to approach the positive infinity. Okay, it's going to go up. Okay. Looking at this, okay, this one's a little tougher. So we're going to find, it's asking us to find the degree, well, describe it, and describe the leading coefficient. Okay, so we're not going to really be able to figure out what specific number they are, okay? But what we can do is figure out if it's even or odd, positive or negative, based off of the direction of the graph. So I know, let's see, these are both going in different directions, okay? When they're both different directions, I know that that's going to mean that my degree is odd, okay? If they both follow the same direction, it's an even. If they're different directions, it's odd. Then we look at our leading coefficient. So this is where we kind of reference our notes here. So as x goes towards the left, it goes up, and as x goes towards the right, it goes down. So that's going to tell me that I'm working with a negative coefficient. I'm working with a negative coefficient. And that is all it's asking for this. Okay. Now let's get into a little bit of a harder problem. Okay. this problem here, it's going to ask us to find the degree, the leading coefficient, the end behaviors, the y-intercept, and the x-intercept, as well as try to graph a potential possible graph for it of what it might look like. Okay? We could try to be more exact with it, but we don't have to be super precise for this specific example. Okay, so how do I find the degree when it's already all factored out for me? See how our problem is already factored. It's not, they didn't leave it in that correct form that we were working with before. Okay, so what would happen is essentially what you could do is you could multiply these all together, and eventually you would get to the original problem. Okay, you could get back to the original problem and figure out what these all specifically are for their values. Okay, but we can kind of shortcut it and look at the things that we need to. So the way we find the degree is we're taking all the x's, we're multiplying them all together. Okay, and when we multiply numbers that have the same base number with an exponent, even though we don't see it, right? Everything's to at least to the 1 power. Okay, we add those exponents together. So this is really going to be x to the 1 times x to the 1 times x to the 1. So I add the 1 plus 1 plus 1. That's going to get me at least x to the third. So I know that my degree is going to be odd. Then we can look at the leading coefficient, okay? So we're looking for the number really out front here, okay? So if I multiply this all out together here, right, I'm going to get -2, okay, as the leading coefficient. So I know that it's going to be a negative, and that's all I really need to know for that. Okay. Now we can still specifically state what these are, but I'm really looking for odd or negative. Okay. Let's look at our end behaviors. So our end behaviors. Okay. So if we have a odd and a negative, okay, that tells me here that these are going to go in different directions. So the degree tells me, hey, it's odd, we're going different ways. So I can look at my my reference here and figure out, based off my leading coefficient being a negative, that as our x goes towards the left, our y value, so our f of x, will approach the positive infinity. So it's really just going up. Okay. When we go towards the right, it's going to go the opposite. So it is going to go down. So f of x approaches negative infinity. Our y-intercepts. So the way we find our y-intercepts is essentially we're going to replace all our x's with zeros. So we're going to replace any x in the problem with a 0. So we get -2 times the quantity 0 minus 2 times the quantity 0 plus 1 times the 0 minus 1. Okay, so working this out here, we get -2 times a -2 times a +1 times a -1. Okay, which gets us -4 times a -1. Oh, sorry, +4 times -1 and a -4. So our y-intercept is -4. Our x-intercepts with the multiplicity. Okay, so we're looking at our parts here. So I got everything here, right, is part of the factors. So we get -2, and we'll set it equal to 0. We'll take our x minus 2 and set it equal to 0. Our x plus 1 and set it equal to 0. And our x minus 1 and set it equal to 0. Now -2 equals 0 doesn't really work for us. So nothing really is going to result from that. We just kind of cancel that out. If we get the x minus 2 is equal to 0. Okay, we can add 2 to both sides. We're going to get x is equal to +2. We can subtract 1 from both sides. We get x is equal to -1. And finally, we can add 1 to both sides. We get x is equal to +1. Now, all three of these have a multiplicity, so we can just say m is equal to, not m. That might get us confused with slope. We'll say the multiplicity is equal to 1, so the mult. Since I only have one of each. So let's put those on our graph. So we have x equals 2, x equals 1, x equals -1. Okay, I know going to the left, my graph is going to start kind of up here, going up, and then it's going to come down through this point because they all have multiplicity of 1, so it just passes through nicely. Okay, it's actually going to hit here as our y-intercept is -4. Pass through here, go up to some point, and then back down. Okay, I'm not asking you to be super specific with how these look and which points they pass through. They make sure point, if they can go through the y-intercept, let them do. If they can't quite, that's all right too. For points like this, it could go all the way up here and all the way down. It could go just to right there, so long as I see that it's passing through and going down at the end. So I need to see the end behaviors, and I need to make sure you're actually kind of shaping it right? Okay, I want you to take a moment, pause, try this problem number here. So try problem number 2 on your own. Okay, hopefully you've had enough time to look at that. Let's go through this problem. So, our degree, okay, we're adding all our x's together. But this is where we got to make sure we're being careful with it, because our x's, okay, we have some squares and cubes here, okay? So really, when we're multiplying these out all together, right, this is really going to become an x squared, this is going to become an x cubed. So really thinking about our x's, right, we've got a 3x times an x squared times an x cubed times a 2x, okay? So, working this out, okay, we have an x to the 1 and x to the 1, so 1 plus 2 is 3, plus 3 is 6, plus 1 is 7. So we get an x to the 7, okay? We can also take the 3 times 2, we'll get a 6x to the 7. So this is really going to be our largest term, right? Now, looking at that, we can see, hey, our degree is an odd. It's an odd degree, and our leading coefficient is a positive. Okay, so let's just leave it like that. So we know that. So based off of this being an odd and this being a positive, okay, we can determine our end behaviors, okay? So our end behaviors are going to be, as it goes to the left, our y goes down. As our goes towards the right, our y goes up, okay? So we can also write f of x approaches negative infinity and f of x approaches positive infinity, okay? Next thing is looking at our y-intercepts, okay? So that's where we replace our x's with zeros, and then we just solve for y, okay? So y is equal to 3 times 0 times the quantity 0 plus 2 squared times the quantity 0 minus 4 cubed times the quantity 2 times 0 minus 3. So working that out, we get y equals 0 times 2 squared times negative 4 cubed times negative 3. Now we could work this all out, okay? But at the very end, since we're multiplying by 0, it's really just going to equal 0 in the end. So our y-intercept is 0, 0, or just right 0. So we know that we're going to pass through right there. Then we look at our x-intercepts, okay? This is where we're writing out that 3x. So we get 3x equals 2. We have the x plus 2 is equal to 0. We have the x minus 4 is equal to 0. And we've got the 2x minus 3 is equal to 0. So each of these, oops, I don't know why this one's equal to 2. Equal to 0. So each of these are equal to 0. And we're just solving, right? So divide by 3, divide by 3. X is equal to 0. Okay, then we've got x plus 2. So we do minus 2, x is equal to negative 2, plus 4, x is equal to positive 4. Then we would do plus 3, divide by 2, x is equal to 3 over 2. Okay. Now, we also have to add the multiplicities. So this is a multiplicity of 1, because I only have one x that becomes 0. Negative 2, right, squared. So I'm going to have a multiplicity that's equal to 2. For the 4, I've got 3 of those. So multiplicity is equal to 3. And for this one, I've only got another one that's just 1. Okay, so let's plot those points on there. So we've got negative 2. we've got a positive 4 and a 3.5. So 1.5. Okay, so it's going to go down and then it's going to go up. So we're starting down. Okay, we're approaching this. Oh, but at -2, right? As a multiplicity of 2, so we bounce off of it. So it bounces off, then it kind of slinks back up, crosses over at our y-intercept, passes right through it. It's going to go up a little bit, then down through our 3/2, multiplicity of 1. Then it's going to approach and then flip kind of a little bit. So it's going to look relatively like this. Yours should look like this, where it goes up at the end, down at the end. I need to see that it bounces off of this point, and how it goes through this doesn't really matter, so long as I see it bounces here and the directions are good there. All right, and that's it for our notes for today. Hopefully this kind of made some sense for you. If you have any questions, you can post them in the comments below, and I can try to help with that. Otherwise, that'll be all.